What's up, everybody? This is Sebastian. I got my hands on the Google Coral development board and I think it's amazing. To make things clear, it was not gifted to me by Google. I got it with my own money and I had to use eBay to ship it from another country. This tells you how scarce they are in the post-COVID era. With this video, I will show you how to set up this development board. The 4-core ARM CPU is made by NXP. On the board, you will also find 8 GB of eMMC memory, micro SD slot, 4 GB of low-power DDR4 memory, and HDMI connector, which is sort of voluntary to use. 3.5mm standard audio jack. At the bottom of the board, you'll find a proprietary video camera connector. There is also a gigabit Ethernet connector and a Wi-Fi module. This whole thing has the size of a regular Raspberry Pi 4 board, and for that reason I've been reusing the bottom part of a Raspberry Pi 4 case for the development board. Starting from the left-hand side, you'll find 5V USB-C power connector. I marked it with a letter P for power, just so that I don't confuse it with the OTG connector right next to it. The OTG is a data connector, which I'm going to hook up to a separate laptop running Ubuntu. And on the far right-hand side is the full-size HDMI connector. On the opposite side, you'll find a micro USB serial connector meant for debugging the board, one USB 3.0 port, and the Ethernet port. There is also a hard reset button, and of course the largest expansion header on the board, the 3.3V 40-pin GPIO expansion header. Under this massive, actively cooled heatsink is naturally the CPU, as well as the Google Edge TPU coprocessor. The coprocessor greatly accelerates the object inference times, and I will refer to it as TPU in the rest of this tutorial. Google has created this fantastic tutorial on getting started with the Coral Edge TPU. It has lots of ready-to-run examples. The initial setup requires flashing Mendel Linux to microSD card and installing it on the Coral dev board. To do all of that, we need some tools, such as another computer. Make sure you have a microSD card with at least 8 GB capacity. Needless to say that all of the existing data on your microSD will be wiped clean. Other tools which are required is a 5V USB-C power supply, and most good phone chargers will do for that purpose. Not initially though, but we will eventually need one USB-C data cable. In case you wonder about a keyboard or a mouse, we don't need any of them connected directly to the Coral board. You may choose an operating system of your choice for the connectivity to your Coral device. Let us first download, extract, and burn the Linux image onto the microSD card with the link provided in the documentation prepared by Google. I already have the free Balena Etcher software tool installed on my PC. If you don't, go ahead and install it, since it will be used to burn the Mendel image onto the microSD card. The process of flashing an image to your card takes anywhere between 5 to 10 minutes, and it all depends on the speed of your adapter and the speed of your microSD card. We can go ahead now and set the Coral board micro switches to boot from the micro SD. A toothpick will do just fine. Flip the micro switches to on, off, on position, starting from the radiator side. In my case, I only had to flip the switch number 3 and 4. Go ahead and insert your microSD card into the card reader and into an available USB port on your PC. Fire up Balena Etcher. Choose Flashing from a file. From the available options, choose your microSD card reader drive letter. In my case, it is the letter E. For me, the flashing took 7 minutes. Go ahead and remove the microSD card reader and insert the microSD card into the Coral development board. The Mendel Linux installation process is not a quick one. I recorded what is going on with the Coral dev board during installation to show you all. Connect the power to the Coral board without connecting the OTG cable to another computer. Just the power supply. Google recommends waiting 5 to 10 minutes for the Mendel Linux installation to complete. I would say wait at least 10 minutes and not less. The installation is quiet if you have no monitor to hook up, but it finishes with the board powering itself off and the red LED turning off. I was impatient in one of my tries and I accidentally interrupted a running installation. Coral board luckily survived disconnecting the power during installation process. During the installation, while the board is on, the red power LED is illuminated. It turns out that after nearly 10 minutes of patiently waiting, Mendel Linux is now installed on this Coral. With the red LED off, we are ready to remove the power cable and the micro SD from its socket. With some help from a toothpick, change the position of the micro switches to their original positions, namely on, off, off, off. I also found what I think is an ambient pressure sensor on the board. Now is the time to reconnect the Coral and boot into Mendel Linux for the first time. Feel free now to connect the OTG cable to Coral on one side and your Ubuntu machine on the other end. For me, it took exactly 3 minutes to boot the board. This is how the Coral's screen looks like when Mendel gets installed. The next day, I am booting Mendel Linux and it took much less than 3 minutes. On the host computer, we need to install some tools to communicate with the Coral via OTG. In my case, these tools have already been installed in Ubuntu. Connect the OTG to your host computer and run mdt devices command. Connect the OTG to your host computer and run mdt devices command. It should list your Coral board now. Issue the mdt shell command. This will allow your devices to establish a secure connection for the first time. Let us connect to the Wi-Fi network. With the nmtui command, we will set up the Wi-Fi connection. Coral can see 5 GHz Wi-Fi networks. And voila, we are connected to a wireless network. Update and upgrade did not proceed as smoothly as expected. And finally, the time to run our first demo. There are 2 different ways to run it. One is displayed by the device via HDMI. The other way is by streaming on a local network. We will be performing inference on a clip with the help of Edge TPU using the TensorFlow Lite API. while the demo is running, by pressing the N button, you are able to switch between models, performing inference on the fast edge TPU or on the device's NPX CPU. And here comes the demo running right now on the edge TPU and identifying individual cars on a freeway. The inference time is in tens of milliseconds with around 70 frames per second. When I press the N button, the inference is now running on the CPU of the Coral. You will immediately notice that the amount of frames per second has dropped to around 3 and the inference time is now much higher. Another press of the N button brings you to the inference on the dedicated edge TPU. Pressing the Q button will cause the demo to exit. Sending the sudo shutdown now command will turn off Google Coral remotely. Just like in Raspberry Pi, in order to reconnect, remove and reinsert the power USB-C cord. My Coral is running release 10.0 of Mendel Linux as of today, and the Python version is 3.7.3. There is another way to run the demo. This way, no monitor is required, and you can see the stream on any device and in any browser. To do that, type into your browser 192.168.100.2:4664. You can also switch between the edge TPU or CPU inference models by pressing the N button. Google had prepared an abundance of great examples of how to perform object recognition, tracking, classification, and many others. Let us download them from GitHub. First, I will make Coral directory and cd into it. Next, I will clone some libraries and cd into the PyCoral folder. Let us first satisfy some requirements listed in the bash file for all of the examples from Google. Right now, let us quickly classify an image of a parrot. The inference times are supposed to be within milliseconds, with the longest time for the very first inference. And it all works just as expected. Congratulations and thank you for bearing with me to the very end of this tutorial. There is a lot more to discover, and I plan on continuing this tutorial with this fun coral board by Google. Cheers!